Hello? All right, the class has started for Java. We're talking about Java. We're talking about Java. And we're going to start it like this. And I sent a link earlier on, but unfortunately, I now had to give that link out for some other class to use. So I'm sending another one now, which I believe you guys can log in. If you are online, can log in, and you'll be able to see and hear us as we start, to see and hear us and see all the things we want to explain in this class. So we're going to start with the very first one, which is what is OOP. 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 OOP is object-oriented programming language. Object-oriented programming language. We talk of object-oriented programming language as OOP. Object-oriented programming language is the class. It has to do with has to do a lot with those items that we are talking about. Sit up so I can be. Yes. We see, I want to share some stuff now. I'll be sharing it so you can see what it's all about. If you have issues or questions, you can easily put it on the comments. I've opened this comment so it's free for everybody to put your comments of your choice. You can ask questions there. And of course, we'll be able to answer you clearly. Now, what is OOP? OOP. What is OOP? Object-oriented programming language. OOP. About OOP, that's OOP. We're talking about what? Object-oriented programming language. Now, when you say something, I'm starting from the very beginning. When you say something is a programming language is OOP, that means it must have some features. It must have some features. And these features is what we'll start with to discuss. The very first feature of OOP is that it must have something we call inheritance. Inheritance. It must have something we call inheritance. And what is this inheritance? Inheritance simply means that a subclass or subobject can get the property of a super object. A sub-object can get the property of a super object. So that's what we mean by that particular inheritance. If you look at it graphically, you can see from the screen I'm sharing graphically, because I'm sharing more than one stuff. So you'll see the second one I'm sharing automatically. Okay, you see this particular object. This is an object. If I have this object, this is an object. They will now have smaller objects, smaller object. This is a smaller one. Maybe I should use another shape so you see. This is a smaller object. You understand? Now, if this particular object, this particular one now, is going to take the properties, this particular one that looks like love shape, is going to take all the properties of this particular one. It's going to take the properties of this. It is called inheritance. So if we assume that this particular one is filled with red. What will be the properties of this? Automatically the same thing, because it's taking the property of that class. So this second one has automatically taken the property of this first one. So that is what we mean by inheritance. And each of them can be regarded as what? An object. This object. So this is the parent object, and this is the child object. This now is the child object. And it is this particular one that is taking the properties of this. So if tomorrow this property changes to yellow, if it changes to yellow, automatically the child changes to yellow because he inherited the property. If it tomorrow it changes to blue, automatically the child will follow and change to blue because of that particular thing called inheritance. It's inheriting the properties of that particular object. All right. Another one we have is what referred to as the multiple inheritance. We talk of multiple inheritance. So number 2 is what? Multiple inheritance. We talk about multiple inheritance. That means a subclass or object gets the properties. The way you talk about properties now, you mean we're talking about method, the properties of 2 or more super objects. So it gets the properties of 2 or more super objects. So that's what this particular do, the multi inheritance. So if we are to still look at it graphically, you find out from our drawing that we have already, this particular love shape is inheriting the property from this particular object. So if you want to now to multiple, all we'll now do is, okay, it should get the property from here too. If possible, you should also get the property from here. So automatically, this love shape is going to have these 3 properties. So if we now say this one is blue, this one is red, and this one is yellow, automatically this particular child object is going to have what now? It's going to have a lot of let me just do some magic and see if you get, if you get it. Okay. Okay, so it's going to have those 3. It's going to get the properties from the 3 of them: yellow, red. Okay, I didn't get that last one. Okay, and blue. So it's going to get the properties from 2 of them. So once you get the property from the 3 of them, automatically it means that it has gotten the properties from, yes, so you can now see, finally I got it. It has the property from blue, it has from this one yellow, it has from this red. So this particular instance, this one now, this one that I'm moving up and down, so it's called multiple inheritance. It has inherited from 3 superclass, so it's called multiple inheritance. All right. Another property is when you say something is OOP, another thing it should have is what we refer to as encapsulation. Encapsulation. When we talk about encapsulation, it simply means you are hiding the implementation. You are hiding the implementation. When you now have a particular stuff, you hide the method that you used to do it. So that other particular people cannot easily access it. So you hide the implementation. Like the program I showed to you now, of course, you are not seeing how I'm doing it. It's encapsulated. You are just seeing the output. I'm not seeing how I'm moving left and right to get this particular stuff done. All you're just seeing is seeing this. So it's encapsulated, what you are seeing there. So another property is what we refer to as error handling. Error handling. So you have number 4, error handling. OOP should be able to handle error efficiently. To be able to handle error efficiently. So when you have an error, you can easily just arrange the error and get it a particular user-friendly code. It also have what we refer to as input-output routine. Input-output routine. This input-output routine, it takes care of the input. If, for example, I have a program and I ask you enter your name, enter your age. Let's assume I say this is a program, enter your age. Then instead of you to put 12 or 1 as your age, you now decide to type ONE. You see that input error is 1, but it's not the type of 1 that we want. We actually needed 1 in figure 1. But if you now enter it in words like this, an input error will occur. So you're able to handle errors. Then you have data abstraction. Data abstraction. When we talk about data abstraction, this is the ability to create different particular things of your choice. You can create different particular things of your choice. You can create new data types. You can actually create new data types. So when you talk about OOP, example of programming language of OOP include Java, Smalltalk, and the rest of them. Now, we are going to talk about how you can get NetBean. You know, you can use, instead of using your command prompt and what have you to do it, you can actually use your NetBean or your code blocks to write this Java program. And I will just drop the website where you can download the NetBean. If you have chance, you can download it on your computer, definitely not on your phone. As computer science student, you should have a computer, so you should be able to download it on your computer system, so you can see that is that. So I'll drop the link for that. So I assume that you do that at your own pace, so we can continue. Now, from the textbook, we have data types and operators in Java. Data types and operators. What is data type? Which is another heading. Data type. We talk about data types. They are talking about the kind of item a variable can accept. And I believe you must have been taught what a variable is when you were in ND1. So data is the kind, the type of data. Okay, let me say items that a variable can accept. So that is what we refer to as a data. Now, in Java, we have different types of this data. We have the one that we call the byte. The primitive, okay, there are two distinct types, primitive, and then you have the other one that is called non-primitive. So you have the primitive and the non-primitive. The other one is the non-primitive. So you have the primitive and the non-primitive. So we talk about the primitive. Those are the one that comes directly with the program. Those are the ones that come directly with the program. For example, you have your bytes. This is where you have your bytes. You have your int. You have your long. You understand? So I believe you must have done some of all of these where you were in the one. Your int, integer, positive or negative number without decimal points. Your long, positive or negative number without decimal points. You also have your float. Positive or negative number with decimal points is what is float, and so on and so forth. And I think there's one called Boolean, where you can only take on a value, either true or false, 1 or 0, 1 or 0, yes or no. So these are that. Then when you talk of the non-primitive data type, these non-primitive data types has to do with what we regard to as like array. You want to create an array. Remember in our last class in school, I gave you a wonderful assignment to create an array. So non-primitive data type allows you to create an array. You can also create classes. You can create objects. All these are what referred to as what? Non-primitive data type. Now that we have known the attendance, somebody is asking for attendance. People love attendance too much. The attendance is directly here. We'll be seeing everybody's name that is there, all your comment, everything. It's all here. So I will get my attendance from here. the Risk to Prosper or Rukomea. So make sure you log in with your name. Oh. When you log in with a name that is not a student, you're on your own. So I was seeing it directly from here for my attendance. All right. So let's move on. Now that we've known this type, you find out that the next thing to discuss, I said we are talking about Java data type and operators. So what's an operator? In one of the class which you people missed, those in AMB, we talked about Java operators. And there, and I explained to them that you have operand and operator. Operand and operator. So he said, what's an operand and what's an operator? So an operand is usually the variable, while the operators is what do you want to happen to the variable. That's putting it in a layman's way. The operand is a variable, then the operator is what do you want to happen to a variable. And you know our popular example, we will say x, we are looking for your x is equals to a plus b. You discover from this that x is equals to a plus b. When you have it like this, all you need to do now is know that the operand are x, a, and b because they are the variable. And the operator is simply the plus because that is what is telling the plus and the equals to. That's what is telling the operand what to do. So that's the operator. So if you're asked what's an operator, you can say, okay, they're usually the symbol that is used to perform an operation on a variable. The symbol that is used to perform an operation on a variable. While the operand are just basically variables. Now, so we are going to be looking at we looked at so many operators. So let's start with the simplest operator. Okay. You have your material, page 14, 15. That's where I am. We have something like, let's just put a simple code there. Int x is equals to 10. X is equals to 10. Then we now have system dot out or print line x plus plus. I remember giving them this. This is an operator. We are talking about the plus plus and minus minus operator. This is the heading for this. The plus plus and minus minus operator. So you have system.add.println. This particular system.add.println simply displays something on the screen. It's saying, oh, display something on the screen. That's what it's doing. So where are you going to display it? You are picking the system. This is the object, the class out. Then this is the method, print line, see x plus plus. But if you look at it, our area of discussion now is the operator. X here is the operand, the variable name. X is the operand, is the variable name. Automatically, x is equals to 10 here. So the output of this particular thing is going to be what? 11. Because as you can see, you have your plus plus here. So 1 has been added to x. So it becomes 10 plus 1, which is what? 11. So in other words, x plus plus is the same thing as x is equal to x plus 1. So just add 1 to it directly. Now, on the other hand, if it was, okay, let me not be deleting it. So, okay, since it's a system, I can easily just do this, copy and paste. If we have it on the other hand like this, let's call this one y now. Y is equals to 10. Then we'll now have plus plus y. Plus plus y. So what will now be the output for this? Plus plus y. For this second one, what will be the output for this one that is highlighted? You see? Y is equals to 10, but you have your plus plus y. The output for this automatically will be 10. Sorry there. The output will be what? 11. In this particular one, the output will be 10. Because in this particular one, it displays this x first before adding 1 to it. In this other one, it adds 1. This plus plus means add it first before displaying it. So if you can look at it clearly, you find out that the plus plus y, you add your 1 first before displaying it. But in this other one, display the value x first, that's 10, before adding 1 to it. So the answer will be 10. After the answer has been given as 10, to now add 1 to it to give it 11. To actually see it like that. It will, in the memory, after it has displayed the 10, it will add 1 to it. So it simply means display the value of x first before you add 1. This plus plus before you add 1 to it. Of course, x plus plus is equals to this, but you display the value of this first before you add 1 to it. This other one, it simply means okay, it's plus plus, add the 1 first to the y before you now display. So you see, add the 1 first to this. That's why the plus is in front, and it's 11. If we are to turn it the other way, let's assume we turn it the other way. Maybe I should just do this. We turn it the other way. Let's make this one W and this one Z. Z. I will now put our minus minus here. Remember, it's plus plus and minus 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 minus. I'll put another minus minus. What will now be the output for these particular programs? The output for these particular programs. Since it's minus minus, as usual with that of the plus plus, is going to give you your x first. So the answer here will definitely be 10. After that, it will now do the subtraction and you have 9 there. In this other instance, Z, oh, I didn't change it. This W. In this other instance, is going to give you the value of it's subtracting 1 first before displaying Z. So your answer here will just automatically be what? 9. Just be 9. Okay. The risk to prosper. How do you write a program using a variable that is constant? It is said that constant doesn't change its value, right? Of course, you can. A constant does not change its value. That's what we said, and that's how it stands. A constant does not change its value. So if you want to write a program using a variable that is constant, we will get to that because there's constant there. So we'll definitely talk about constants. But for now, we're talking about variable. Variable, the content can change. The content can change. But for constant, the content cannot change. Once you give it a value, automatically that value is what it will just have, and it will not be able to change it. A constant, the value cannot change. But for a variable, the value can change. Now, we discovered that we have done that plus plus and minus minus. So let's move on. Actually, to define a constant in what are you calling it, in Java, you use the final keyword. It's simply a variable that uses the final keyword. By doing so, you are telling the computer that, oh, this thing is. Let me just see if I can get you some. Let me see. Okay, sorry. Okay, you use the final keyword. So if you have a particular one now, this one final double pi. Final is the keyword to say it's a variable. That's final answer, final. This is the type, data type. Remember I talked about data type. I mentioned it float double to accept numbers with decimal point. Then this is the name of the constant, pi. The name of the constant, pi. And they have now given it a value. Pi is equals to 3 points. This. Can you see it? Now, if we come out here and we say system.out.print, the value of pi is plus pi. This one will work. You see this line that I've highlighted will work. Can you see it? Because it will automatically display 3.14159, this one. But if we now come to this line, this are comments. If we remove this comment and we come here and we say pi is equals to 3.14, want to change it, it will cause an error. So you can see it cause an error because pi is final, is constant. So this line will cause an error. That's why it is commented out. I commented it out when you ask. I commented it out. All right, back to our explanation of operators. All right, so we are talking about these operators. We have another operator that is very easy. This operator, all of you know it, to add, to subtract, to my the arithmetic operators, you know all of them. So I will just quickly list them out. And the arithmetic operator, you have your plus. This is for addition, to add. You have your minus. This is for minus or subtraction. You have your star. This is for multiplication, multiply. You have your divide. This is slash for divide, and so on and so forth. So these are some of your simple, particular stuff that you use for that. Okay. All right, so let's continue. Let's proceed. So if we have these simple arithmetic operators, of course, you all know the board mass. Board mass. I think board mass is like this in mathematics, where it means simply means bracket, brackets of division, multiplication, addition, and subtraction. Add, subtract. So this is just the basic. Maybe I should write it in one word so you see it. So this is just the board mass. The B for brackets, O for of, D for division, multiplication, addition, and subtraction, which I believe a computer will not change to bed mass, something like that. The same B for this brackets, where this other one now is now for what? The E is now for exponential. Exponential simply means raised to power. When something is raised to power, raised to power. So you can say 10 raised to so power, what have you? 10 raised to power 2. So that's what exponential simply means. You raise something to power. Then, of course, our D is still division, our M is still multiplication. So the only difference is just this of instead of now make it raised to power. Now, why is it important? If we have, let's say we have int A, B, answer. Okay, let me not do instant declaration, giving it a value. They will now say A is equals to 4. B is equals to 2. Answer. Let me just say system dot out dot print line is equals to answer is equals to answer. So automatically doing this particular one, if I now have answer is equals to A slash 2 plus B, what will be plus B? I think I should space this one out so you can see it clearly. Just to for space sake, A slash 2 plus B. If I have this particular one, so what will be displayed there? Some people might be tempted to do this first. You know, if you do this first, it becomes automatically 2 plus 2, 4. So let me just copy this out. I want to copy this out for explanation's sake. So if you do this one first, automatically it becomes we're getting something totally wrong. So if you do this first, you have this. If you now decide to do these two first, automatically your answer will be A slash 4. Because remember, B is 2. B is 2 from our program. From our program here, B, okay, let me get all of that. Let me just get everything out here so we can follow at the same time. Okay, this is our program. So you can see that B is 2. So what I've done for this particular one, what I've done for this one, 2 plus b. So 2 plus b automatically, if we do for this, we'll be wrong because we're not supposed to do for that first. But nevertheless, let's assume we have done for that. So I've gotten a over a divided by 4. So a divided by 4 will now give us, a is 4, 4 divided by 4, and that will give us 1. And you might be happy that that's the right answer. Unfortunately, that is not the right answer. The right thing to be done is to using the board mass. Remember, using our bed mass now, BEDMAS, bed mass. Bracket. Is there any bracket here? There is no bracket in this particular equation, so we'll not do it. Exponential. Is there an exponential here? No exponential. The next one to do is division. So automatically, we are going to do a divided by 2. And a divided by 2, the right thing is a divided by 2 will give you 4 divided by 2. And 4 divided by 2 automatically is 2. When you divide 4 from 2. Let me delete this wrong answer from here. When you divide 4 divided by 2, automatically you have your answer as what? 2. Then you can now put the plus b. Remember, so when you come under, you can now say, okay, 2 plus b now. What is b? 2 plus, remember, b is 2. Look at it, b is 2 from here. So 2 plus 2. So the right answer is 4 based on our bed mass, based on this bed mass that we're using. If you don't use it, you just have to do it as the spirit leads, you definitely get the answer. And this is a very simple case. What if we now have a situation where we now have something like this? Answer is equals to bracket open a minus 6. This is just an example. I'm not solving it. You can try it. Plus b bracket close divide by a time. You understand? Something as long as this. So how do you do? How do you do if you now have something like this? And it can be as long as anything. Of course, in this particular one, you have to do the bracket first. You have to do the bracket. This is the first thing you do because the b. After that, you now do no exponential. So you now do this divide next. So you do next one is to do this, the second thing, before you now multiply to get your answer. If you decide to multiply these two first and do this one next and then divide, you all know, or you decide to do this one first, this part, then you now do this one second, then you divide the two answer, you'll be totally wrong because you did not follow the rules of board math. This particular one, this, if I'm to write it in mathematics, no, this is in computer, it's going to look like this. So let me write it like this one now in mathematics. You will now see how it looks like. Answer, I hope I can get that correctly, is equals to bracket open a minus 6 plus b bracket close. Then, of course, there's a line. If I have to do it like this is the line. Then we have a, only a here. Then you can now have our times b. So this is how it is in mathematics. So if you look at it in this math now, you see that, oh, you can easily get it. Oh, you can easily get it. Oh, boy. Yeah. You can easily get the answer because this is how it is. It's the same thing that we just translated like that. So you should not get it twisted. Okay. All right. No voila. Some of you say what? No need to say it. Okay, so those are some of the operators. So if you see something like that in the exam, no matter how long it is, you should be able to sort it out. Now, another one I want to talk about briefly today is what we refer to as control structure. Control structure. When we talk of control structure, what do we mean by control? These control structures are just simple things that tells the program where to go. the control structure say, okay, you are coming from the left, go right, or you are coming from the top, go left. So it controls the direction of flow of the program. And we have different types of control statements. You have one that is called decision control statement. You have the other one that is for looping, and another one that is for jump statement. So let's start with the decision making statement. We are talking about decision making statements. Decision, we have two types. The decision making statements. Decision. One of them is, of course, the popular if statement. The popular if statement. So you have your if statement. If statement. The if statement. This if statement is used to make a program go in a particular direction based on a condition. Based on a condition. It's used to make the program go in a particular way. So if we are to do it, let's do an example now. Let's say we have, and let me just get it out. Int x is equals to 10. Int y is equals to 10. Automatically, if x plus y is greater than 20, what are we now going to do? You see, this is the condition. So if it's greater than, what are we now going to do? All we need to do is just to put our system.out, print something, for it to print something. So I have to just copy that and paste here. Automatically, that is what I just wanted to print. I wanted to print welcome. Let me just put it, welcome. Welcome. We open it here. We open this thing here. So we must definitely close it. So we'll have closed it. All right. So if we have this particular program, all it will do, still based on that board mass. Remember the board mass? But this is very simple way. It's just plus x plus y. So 10 plus 12 is 22. So is 22 greater than 20? Yes. So what you will see is what? Welcome. If I just put a simple minus here, the program has changed, because 10 minus 12 is what? Minus 2. Is minus 2 greater than 20? No. So it will not print this welcome again. The output will not be welcome. So you can see, simple changing of an operator can affect the program flow. If I change this other operator, this is the relational operator. If I change it to less than, automatically it's going to print welcome, because x minus 10 is minus 2. Is minus 2 less than 20? Yes. So it will now print out welcome. So you see, so that is how we do control. That's how we do control for the decision statement. That's how we do control for the decision statement. Now, let's still talk about one more thing before we free people to go and sleep, because I know many people already say, this man, quick talk, quick go rest. All right. But this if statement can be made longer. What if you have more than one condition, and you want to specify the condition? So you can now use the else and the else if statement, the if else if statement, the else and the else if statement. So let me just quickly get something out so you can easily see what I'm talking about. Okay, the else. I'm typing it, so I'll just post it there for you to see. Okay, all right, so let me paste it so you see, because it's going to be a little bit bulky. We'll talk about this if, else if. It's basically like this. If, okay, let me just see if I can get that. Now, maybe I should delete all these ones so you can have space to see what I'm saying. All right. So this is it. If I like writing it like this in class. If condition, it will do whatever is there. Else, if the condition, another condition, this is another condition, it will do what is there. Else, if these two conditions are not met, it will not do this. It will not do that. So let us see a simple Java program that I've run already, and we'll see how it looks like. So this is it. This is the Java program. Public class, grade checker, public class, just to check grade. We are now saying int. This is the name of our variable score. And the data type we can accept is int. The value here is what? 85. We're now saying if score, this is the condition, if score is less than or equal to 90, print A. Is this score 85 less than or equal to 90? It is not equal to 90, but it is less than. So it will not print it out. It will now go to the next one. If score is less than or equals to 80. Is it equals to less than 80? No, it's not. So it will now skip that. If it will keep going, see, these are the conditions. To test them one after the other. And at the end of the day, it will now give us the answer. And the answer in this instance is going to be what? A. Because it's less than 90 and it's greater than 80. So your output here is going to be what? This first one, A. If we change this to 15, automatically the output has changed. The person, if it's less than 60, of course, the person failed. And I pray none of you will fail this course. Amen. Amen. All right, so I think I'll stop here. Maybe tomorrow or Friday we'll meet again so I can continue from here. Because even me, I've been working since morning. So let me take a little rest. Okay. If there's any question, you can easily put it on the group chat so that I can answer you before we all take a bath of here. Okay. I'm going through the comments. Let me get. Okay, so I've gotten the list of the people that are here, and as usual, that is my attendance. Thank God, this is digital. You cannot lie that I came when you did not come. The video will be there to tell you, you're lying. Then you can always rewatch it again. You can watch it again anytime. Just click on the link. You can watch it again and again. So good night, everybody, and God bless all of you.